Yeah, hello students. I hope you might have watched my previous two videos before watching this, because I've solved some simple problems in my previous two videos along with another video which says about Nyquist stability criteria steps involved. So now in this particular example, what you can see here is, as I said I was saying you always, like, we have one pole at the origin. Okay, so it is s into s plus 1 into s plus 2. So you can see that there is one pole at the origin. Okay, so therefore this will be a different contour now. The second contour in the first video of Nyquist criteria, which I have explained. So that is the contour which we are going to write now. So let us write it. The contour, initial foundation, the Nyquist contour is what which is very important for us to write in the beginning. Then we will come to know which path and all we need to trace. So that is very important. So here you will be able to get us a small semicircle. So that is very important. So you will be able to get a small semicircle. Okay. Small semicircle. I'm sorry. So this is a small semicircle which we get. And we do also have a big one, which is a semicircle. This one. Okay. Now this is A, this is B, this is C, D. Now you get two more points, which is E and F. Okay, these two more points. Now I told you earlier, this big circle will be R tending to infinity, whereas this small circle, what you can see here, is R tending towards, small circle R tending towards 0. And here we take R into e power j alpha, pi, whereas here we take R into e power j theta. I think you'll come to know once I do further steps, you'll come to know whatever I'm saying. Anyway, here this is plus j infinity, omega is infinity, angle is 90 degree, whereas at C, the angle is 0 degree, whereas at D, angle is minus 90 degree. Okay. Now if you see with A, point A is not now at the origin, point F is on the line, point E is again not exactly at the origin, which we saw earlier. Okay, this is the contour which we are going to trace in the further is what we solve this particular problem. Now first thing what we need to do is pole zero diagram. I'm just trying to find out what the value of capital P. So we have one pole at the origin, we have another pole at -1, and we do have another pole at -2. So we don't have any pole towards right half of S plane. Therefore, the value capital P will be equal to 0. The value capital P will be equal to 0. Have you got it? So this is the first identification. Value of P is equal to 0. Now we need to find out the encirclement. For that, we need to go step by step. Now, what are the paths we normally see here is, for this particular problem, we are going to trace the path. So we get 4 different sections here now. So here section 1 is as usual the path A to B. Section 2 is as usual the path your B, C and D. Now section 3 is not BA now. Section 3 is path D and E. Now you get another section, fourth section. So this is third section. Now we do have fourth section, which is the path E, F and A. E, F and A. So therefore, the tracing what we do here is A, B, C, D, E, F and A. So these are the tracing we go with this particular problem. Okay. Now let us first go with the first step. Let us go with path AB. So take the problem which is given, where G of S into H of S is K divided by S into S plus 1 into S plus 2. As usual, what we do is we'll try to substitute S equals J omega. So I'll be getting J of J omega into H of J omega equals K divided by divided by j omega into j omega plus 1 into j omega plus 2. Now we'll try to put all the magnitude and phase like what we did in the previous problem, magnitude and phase. So magnitude for k is square root of k square, which is k, and angle is 0 degree. Why? Because k means it is k plus 0j. So definitely square root of k square plus 0 square is square root of k square is k. Whereas angle is tan inverse of 0 by k. So therefore it gives you 0 degree. So 0 degree. Whole thing divided by magnitude of j omega is square root of omega square. It remains to be omega magnitude. Whereas the angle is tan inverse of omega by 0. And the magnitude of j omega plus 1 is square root of omega square plus 1. And the angle is tan inverse of omega. And whereas magnitude of j omega plus 2 is square root of omega square plus 4. And angle is tan inverse of omega by 2. Okay. So now what I'll do is I'll try to write the angle and the magnitude and angle separately. So what I'll get here is magnitude is k in the numerator divided by magnitude is omega in the denominator into square root of omega square plus 1 into square root of omega square plus 4. So these are the magnitude which we have got. So these are the magnitude value. Whereas angle is 0 degree. In the numerator, in the denominator, I have tan inverse of omega by 0 is tan inverse of infinity into tan inverse of omega into tan inverse of omega by 2. Finally, what we get here is when at point A, omega equals 0. So therefore, what do I get here is here k divided by 0 into anything is 0. Anything divided by 0 is infinity. So we got magnitude is infinite. Whereas angle at an angle 0 degree, tan inverse 0 is 0, tan inverse omega by 2 0 is 0, tan inverse of infinity is 90 degree. This gives 90 degree. So it is in denominator, and if the angle goes to the numerator, this becomes minus 90 degree. So you see that at A, the phase is going towards infinity at an angle minus 90 degree. So when I go with B, where at B omega equals infinity, so therefore at B, infinite multiplied by any value is infinite because omega is infinity, so infinity multiplied by any value is infinity. So k divided by infinity, so anything divided by infinity is 0. Magnitude is 0, whereas angle is 0 degree divided by tan inverse of infinity is 1 angle is 90 degree. And this is omega is infinity, so again tan inverse of infinity is 90 degree. Tan inverse of infinity divided by 2 is infinity, so tan inverse of again infinity, which is 90 degree. 90, 90, 90, you get 270 degree. So therefore, as it is 9 into 3 is 27, so it is 270 degree in the denominator. If it goes to the numerator, it becomes minus 270 degree. Okay, so at A it is infinite at minus 90 degree, and whereas at B it is 0 at an angle minus 270 degree. Okay, so let us now draw this trace. Let us draw this trace of A and B. Okay, now A is infinite at an angle minus 90 degree. So let us first understand these angles. Where is minus 90 and minus 270? If I go with anti-clockwise direction, we will be able to see the angle is positive. Like this is 0 degree, we know. If I go here, it is 90 degree. If I go here, it is 180 degree. And if I go here, it is 270 degree. And further, if I go this side, it is 360 degree. Okay. But if I go towards anti-clockwise direction, if I go towards, clockwise direction, anti-clockwise will give you all positive angle. If I go with clockwise direction, this is 0 degree, but in clockwise, this becomes minus 90 degree. This becomes minus 180 degree. And this becomes minus 270 degree. Whereas this becomes minus 360 degree. Okay. So going anti-clockwise is all negative, going clockwise is all negative, and going anti-clockwise is all positive angles. Now, if I want to show A, which is infinite at an angle minus 90 degree, so the point A will be somewhere here. and it is 90 degree, minus 90 degree. And why it comes here? Because it is tending towards infinity. Okay, it is tending towards infinity. It starts from infinity, sir. Because A is the starting point. So it is starting from infinity. Okay, and to show a proper trace, what I'll do is I'll try to join here because it is 90 degrees. So let me say this is A dash is infinity at 90 degree. Infinite. So this value, what you are able to see is infinite. Now it goes to B, which is having magnitude 0. So therefore B 0 magnitude means it is an origin, and angle is minus 270, and angle is, this is minus 270, this is angle minus 270. So the trace should be like this. So it like this. It goes from 0, it goes from minus 90 degree, and then it should come to minus 270. I cannot trace like this because if I go like this, it goes to minus 180. I should go to minus 270 from minus 90. So from minus 90, if I want to go to minus 270, I should go towards minus 180 and then minus 270. So this is the trace that you get for A dash and B dash. A dash and B dash. I hope you understood whatever I have solved till now. Now let us move further. Now let us go to next section 2. Section 2, which is path BCD. Path BCD. So let us take the problem, which is g of s into h of s equals k divided by s into s plus 1 into s plus 2. So in this step, we know that we'll try to replace s with limit r tends to infinity r into e power j theta. So therefore, our g of r into e power j theta into h of h into e power of j theta will become k divided by, so limit r tends to infinity, k divided by r into e power j theta into r into e power j theta plus 1 into r into e power j theta plus 2. If you see here, r into e power j theta plus 1 is very less compared to r, 2 is very less compared to r because r is tending towards infinity. So I can write this problem as limit r tends to infinity, k divided by r cube, because r into e power j theta, r into e power j theta, r into e power j theta. So r cube into e power j theta, j theta, j theta, 3 times j theta. So it is j into 3 times theta. So I'll further write it in magnitude and angle term. So limit r tends to infinity, magnitude is k divided by r cube, whereas angle will be e power minus j 3 theta. Now, as r tends to infinity, k divided by infinity, anything divided by infinity is 0. So we get magnitude 0 at an angle. We know that in the previous 2 videos we have discussed this angle at B, C and D. We know that angle at B is 90 degree, angle at C remains to be 0 degree, angle at D remains to be minus 90 degree. Therefore, here it is 3 times 90 degree, minus 3 times 90 degree. So when the angle is plus 90 degree, it is 3 into 90, which is minus 270 degree. When angle is 0 degree, it is 0 degree. But when angle is plus minus 90 degree, it becomes minus of minus plus 270 degree. So it means that at B dash, it is 0 at an angle minus 270. At C dash, it is 0 at an angle 0 degree. At D dash, it is 0 at an angle plus 270 degree. So therefore, if I try to draw the trace for this particular section, as the magnitude is 0 for all 3 values, so it lies in the origin. It lies in the origin. As magnitude 0, it lies in the origin. Whereas angle is minus 270 is this, and plus 270 is this. Whereas 0 degree is this. Anyway, as magnitude is 0, all B dash, C dash, D dash will lie on the origin because of magnitude becoming 0. Now what we'll do is we'll go to the next section, which is section 3, which is path D and D. It is not DA, keep that in mind. In this particular problem, it is path D and section 3, which is path D. Let me tell you, this path is the mirror contour of AB. Keep that in mind. This path is a mirror contour of AB. So therefore, if I draw the mirror contour of AB, if you go back and see AB contour, this is A dash is here, B dash is here. Now the mirror contour is this entire diagram will go upwards. So that is the mirror contour. So what happens here is the mirror contour. So here the D dash will be here, whereas E dash will be somewhere here. So this touches this with infinity. Whereas the mirror contour for this one. Okay, so this is the mirror contour, what you can see here. And the distance is still not been found. Whether this particular path crosses minus 1 plus 0j, we'll see that later. Anyway, now this became our path D. Now we still have another path to go with, which is section 4. This is the extra path because of one pole at the origin which we have, which is E, F and A path. E, F and A path. So let us go with E, F and A path now. Here, see, for all problem, when you get any pole at the origin, this is the procedure we go with. In this section, what we do is, in the earlier section, when R was infinite, we took R into e power j theta and R tends to infinity. Here, this is a small semicircle, which I told you, small r, which is tending towards 0. So therefore, we replace S with limit small r tends to 0, R into e power j pi. Okay, this is what we replace. Now let us take the question again. We know that G of S into H of S equals K divided by S into S plus 1 into S plus 2. So therefore, replacing S with limit R tends to 0. So what happens here is limit R tends to 0, R into K divided by R into e power j pi into R into e power j pi plus 1 into R into e power j pi plus 2. Okay, R into e power j pi plus 1, R into e power j pi plus 2. Here, it's quite different. R is tending towards 0, therefore 1 will be greater than this term now. 1 will be greater than this term. 2 will be greater than this term. So what I will write here is limit R tends to 0, K divided by 2 into 1 is 2 times R into e power j pi. So this is what you get. Because R tends to 0 means this becomes 0. So therefore 1 is definitely greater than 0 and 2 is definitely greater than 0. That is why this entire thing becomes just 1. This entire thing becomes just 2. So 2 into 1 is 2. So therefore I will separate magnitude and angle. Limit R tends to 0. K by 2 times R into e power minus j pi. E power minus j pi. So we should know what is the angle at E, F and A. So if you look into angle at E, go back and look into the initial trace. The angle at E and B, it is one and the same, it is minus 90 degree. Angle at F and C is nothing but 0 degree. Angle at A and B is nothing but 90 degree. Okay, so therefore angle at E is minus 90 degree. Angle at F is 0 degree. Angle at A is plus 90 degree. If I put these angles and substitute the limit, as R tends to 0, 2 into R is 0, K divided by 0 is infinity, is the magnitude. At an angle, when E is minus 90 degree, angle is plus 90 degree. When F is 0 degree, angle is 0 degree, whereas at A it is 90 degree, as it is minus, so it becomes minus 90 degree. So therefore, what happens here is at E, it is infinite at 90 degree. At F, it is infinite at 0 degree, whereas at A, it is infinite at minus 90 degree. Now, this is what, you have one important trace which you need to learn here. As magnitude is infinite, so therefore, this case is not like earlier, because as magnitude was 0, we used to write it at the origin. But as the magnitude is infinite, what we'll do, let me tell you that. So the point A is minus 90. So the point A, this is minus 90. Okay, the point A is, so let me say this is A dash, which is at minus 90. The point F is at 0 degrees. So this is, let me say point F dash. Whereas point E is at plus 90 degrees. So let me say this is E dash. Now, as all these 3 points are tending towards infinite, so we will have a semicircle like this. Try to write a smooth curve, semicircle like this. And this point is tending towards, means this curve is tending towards infinity. This is how we write the curve for these 3, E dash, F dash, and A dash. E dash is infinite at 90 degree, so this is 90 degree. And F dash is infinite at 0 degree, so this is 0 degree. A dash is infinite at minus 90 degree, so this is minus 90. So this is infinite. If you go here also, it is infinite. If you go towards any side, it is tending towards infinite. That is what it means. So this is how the trace need to be written. Finally, if you club all these 3 traces, this one, and this one, we will be able to get the final curve, which I am going to write now. So, sorry. So this is the curve which I am going to write now. Now, we had, one curve coming, one curve coming in this direction. Okay. Meeting, this is A dash, this is B dash. And we also saw another curve which is going in this direction. Which is meeting the other point, which is D dash and E dash. And we had another semicircle which we got at the section 4. So I'm going to draw that semicircle now. Which is joining this point. And this is F dash. And we all know this is our infinity. Now 0 degree, 90 degree, and minus 90 degree. And we also got plus 270 degree this one. And this is minus 270 degree. And this is minus 180 degree point. Okay, this is the curve. Now let me write the direction, which is very important. Now we have A dash to B dash. The direction is in this way. And we had B dash to, so this is the direction. And B dash to E dash is this direction. Okay. Now the major point here is the problem is not yet over, because we are able to see this particular circle. Whether we do have this minus 1 plus 0j inside this circle, we need to check, because we don't know what is the value of this point. So now what we need to do is we need to calculate the value of that particular point. We need to find out the magnitude value at that particular point. So to calculate that, what we need to do is we need to take a phase condition. So what is that phase condition here is, now let me take a phase condition. Let me take this point as some x dash. Okay. Now what is that x dash at x dash? The phase should be minus 180 degree. Right? At x dash, if you see the phase is minus 180 degree. Now let me write the phase equation. What is phase equation which we got earlier? What is phase equation here is, this is the phase equation, which is minus 90 minus tan inverse of omega minus tan inverse of omega by 2. So that is what the phase equation we get for this particular problem. Okay. So if you are confused, let me tell you. So g of s into h of s was equal to k by s into s plus 1 into s plus 2 is the problem which was given here. And if you put s equals j omega, what happens here is k divided by j omega into j omega plus 1 into j omega plus 2. And this will be equal to, angle for k will be 0 degree, which we all know. Angle for j omega is tan inverse of omega divided by 0, which is 90 degree. And this will be tan inverse of omega and for this it will be tan inverse of omega by 2. Finally, all this in denominator, if I try to write the angle, the phase will be equal to minus 90 degree because it is denominator, so it goes to numerator, it becomes minus 90 degree minus tan inverse of omega minus tan inverse of omega by 2. Okay, so this is the phase equation. Now this at x dash, at point x dash, this phase equation what we have, we need to see that this phase equation what we got for the problem, at x dash the phase should be equal to minus 180 degree. See, in this curve at x dash the phase should be equal to minus 180 degree. If I want to find out the phase equation, this is the phase equation, anyway this should be equal to minus 180. Now with this particular equation we are able to get omega value. To find out the omega value in this equation. So what happens here is, I'll try to write minus 90 plus 180. I'll take minus 180 this side, and I'll take this tan inverse of omega plus tan inverse of omega by 2 towards right hand side. So 180 minus 90 is 90 degrees. So therefore, tan inverse of omega plus tan inverse of omega by 2 equals 180 minus 90, which is equal to 90. Now we all know the formula. Okay, we got tan inverse of omega plus tan inverse of omega by 2 equals 90 degree. And we all know the formula, tan inverse of x plus tan inverse of y. Formula is tan inverse of x plus y divided by 1 minus xy. Okay, so this is the formula which we have. So by applying this formula, what do we get here is tan inverse of, so in the place of x we have omega, so it is omega. In the place of y we have omega by 2, whole thing divided by 1 minus omega into omega by 2. And this is equal to 90 degree. Fine. So therefore, it is tan inverse of, take LCM. So what do we get here is 2 omega plus omega divided by 2 minus omega square equals 90 degree. So if I see what is tan 90 degree, okay, tan inverse of 2 omega plus omega by 2 minus omega square equals 90 degree. So this becomes tan inverse of 3 omega by 2 minus omega square equals 90 degree. So therefore, this is 3 omega by 2 minus omega square equals tan 90. Or I can say 2 minus omega square equals 3 omega divided by tan 90 degree. And we all know tan 90 degree is infinity. So therefore, 2 minus omega square equals 3 omega divided by infinity. Divided by infinity. Anything divided by infinity is 0. Therefore, 2 minus omega square equals 0. So therefore, omega square equals 2. So omega value equals plus or minus root 2. So this is the value of omega that we have got, which is plus or minus root 2. So let me take omega equals root 2 radians per second. So we got omega. Where this is the omega at point x dash. At point x dash, the omega is root 2. Now, find out the magnitude at point x dash. So we need to go with magnitude of j omega into h of j omega. So you get magnitude of k divided by magnitude of s is j omega, magnitude of s plus 1 is j omega plus 1, magnitude of s plus 2 is j omega plus 2. And if you write magnitude of k, this remains to be k. Magnitude of omega remains to be omega. Magnitude of omega, j omega plus 1 is square root of omega square plus 1. Magnitude of j omega plus 2 is square root of omega square plus 4. So what I do is I'll substitute omega as root 2 because that is the omega at point x dash. So this is the magnitude equation at point x dash by substituting omega equals root 2. So therefore, at x dash, the magnitude is k divided by root 2 into root 2 square is 2 plus 1 is root of 3 into root of root 2 square is 2, 2 plus 4 is 6. Is 6. Therefore, I can write this as k divided by square root of 2 into square root of 3 into square root of 6 can be written as square root of 3 2s are 6 and 6 into 6 is 36. And we know square root of 36 is k divided by 6. Therefore, at x dash, the magnitude is k divided by 6. So go back to the contour now. So this is the contour. Now the point, this point is actually equal to k by 6. So this point is actually equal to k by 6. If the value of m should be less than 1, because if I want this minus 1 plus 0j should be within k by 6, then it all depends on the value of k now. What should be the k value so that x dash will be within minus 1? Within minus 1. X dash will be like minus 1 plus 0j will cover within x dash. Okay, so x dash should be, it should be more than minus 1, like minus 2, minus 3, like that. So the system, the closed loop stage is let to be 0. See, as in this particular problem, what we got P was 0. So I want n also to be equal to 0, such that z will be equal to 0. If I want to have z should be equal to 0, the encirclement should also be 0, so that this circle should be outside. So I need to have minus 1 plus 0j outside the circle. I need to have minus 1 plus 0j here. So it means that k by 6 should be less than this value minus 1. So k by 6 should be like minus 0.5 or minus 0.4, like that, so that it will be before minus 1. Okay, all this point is between 0 to minus 1. So therefore, when k is very less compared to 6, k is 5 by 6, for example, k is 5. What we get here is 5 divided by 6 is 0. So 0.8 something. So we get 0.8. And that 0.8 is not compared to minus 1. So minus 1 plus 0j will be outside that 0.8. So therefore, the condition for z to be equal to 0 is k should be less than 6. When k is less than 6, z is actually equal to 0. And because of n is equal to 0, because this encirclement will not cover minus 1 plus 0j. If the k value is greater than 6, then there you see there will be encirclement encircling minus 1 plus 0j. Okay, then definitely the system becomes, n will be what? If minus 1 plus 0j is inside this point, for example, minus 1 plus 0j is here. You have one circle inside, another circle outside. You have two different circles, and both are clockwise. You see, this is also clockwise, this is also clockwise. As both are clockwise, you get positive 2. N will be 2. Z will be equal to what? P plus 1, 0 plus 2. And Z becomes 2. Therefore, open loop, closed loop control system becomes unstable. For what? K greater than 6. Therefore, in this problem, we finally write K should be greater than 0 but less than 6 for the closed loop system to be stable. So, stability completely depends on the value of K. I think you people have understood this problem. I hope all my explanation was able to convince your thoughts. So this is quite different problem. I think all these 3 videos of 3 different problems, you saw it. It was quite different and little bit of difficulty added into every problem. So hope you have understood, and I convinced you people to understand Nyquist plot within these 3 different videos. In the next video, I am going to solve one more problem, which will cover another type of Nyquist plot. Okay, please watch that video also. Thank you.